Hello, and welcome to the review tutorial on the basics of setting up an SPSS dataset, where we're going to focus on creating and manipulating variables. And this tutorial is meant as a basic SPSS tutorial review, where we're going to cover some of the basic ideas of the views in SPSS, creating variables like string, numeric, coding variables, sorting and selecting cases, computing variables, and recoding variables. And so I'm going to get started by starting up SPSS from my dock. One of the things that you'll notice right away is that working on a Mac, some of the things might look a little bit different, but all the commands are going to be basically the same here. One of the things that you'll see typically when you open up SPSS, regardless of which version you're working in, is that you'll have a submenu that offers to open up an existing data set or run a query or creating a new database. Easiest thing you can do is just close this window out, and that's going to leave you in an open data set with no data, no variables, or anything like that set up. I'm going to maximize my window here so that you can see everything, and we're going to get started by talking about the different views that you have in SPSS. The first thing we'll talk about is that I'm working in what's called right now the data editor. Now, the data editor is really where all the action happens within SPSS. It contains both the data view, which we're currently looking at. It also contains something called the variable view. And you can toggle between those by just selecting those two tabs here. If you're working on a Windows machine, these two tabs are located more on the left side of your screen. Data view is where you'll see what looks a lot like an Excel spreadsheet or an Access database, something along those lines where you have rows and columns forming cells. In SPSS, these cells run horizontally, known as cases, and you'll see that the columns we typically refer to as variables. And in fact, you'll see a VAR for each of the columns currently in an empty data set. Now, right now, we don't have any data in this one, but if we did, it would fill in this data page on the data view with all the things like the values, the numbers, the information or categories for whatever data set we were using. And the data view contains that information. The variable view contains information for each of the variables. And it's organized also in a cellular fashion where we have rows and columns. Typically, we think about this as each of the rows containing information about one variable. So right off the bat, there's a little bit of a difference between the data view and the variable view in that for the data view, typically one case, which goes horizontally, is represented by maybe one person or one point of data collection and contains multiple variables out to the right. Whereas in the variable view, each of the rows is actually one variable. So it's sort of transposed when you think about the structure of an SPSS data set. And oftentimes you may want to use SPSS to import data that you might already have in a different format. One of the common ways that people often will import data is from a Microsoft Excel program. We're going to start though with having no data in another format, how we would create an SPSS data set from scratch. The best practice, although it might be tempting to go ahead and start entering numbers and entering data into the data view here, it's actually a much better idea if we go to variable view and start setting up properties for variables that we would wish to enter. And so as I do that, we'll start with some basic data points here, things that are not uncommon to be included in a data set. The first thing that we have to decide is what we're going to call our variable with regard to a variable name. Now, variable names do have some restrictions in terms of a variable name can't contain spaces, it can't contain certain special characters, and so we usually keep them brief, abbreviated, whereas later on we can give them a more specific name under the label. And so under name, we'll start with SUBID for subject ID. And if you type that in and then hit the enter key or the return carriage, you'll see that heads to the next variable where we could enter information. And SPSS has put a lot of default information in for the variable subject ID. Now, that's nice, but lots of times that information is not the information we'd want to have set. And so it's good practice to go through and make sure all of the properties for this variable are set appropriately. And we'll start with type. And so we've got name in for subject ID. If you click on the type, over on the very right side of that cell, what you saw was little 3 dots that pop up, a little ellipsis. And if you click that, it opens up a submenu that tells us about variable type. So variable type is going to be information with regard to the properties of the types of data that will be in there. So if we're talking about numeric values, or we're talking about string values, or is it a date function, things like that that you would choose from. Now, most of the data that I deal with, and most of the data that most of my students deal with, and when I do consultations, we're dealing with numeric data. Numeric data typically has properties where we could use comparators to say one is greater than or less than something, or we could add values or even multiply or divide values. And numeric properties allow us to do that. However, there are some cases where we might put in a date format. Say you wanted to list the date when something happened, or you wanted to put a birth date down for a subject. You could use the date function for that. Oftentimes, we'll use string data for information that we don't have any interest in using comparators or any kinds of functions for, that we would need the numeric values for it. A good example is that if I were keeping a database of information for participants and I wanted their address in that database, that kind of information wouldn't be anything that I could use to add or subtract later on. And so I would use that as a string variable. There are different forms that you could use here. I won't go over all of them, but we'll go over a couple of them as we go through here. Like I said, numeric is typically the most common one that you'll use. And when you choose numeric, you could also set the width and decimal places for that variable as it shows up in your data set. So if you wanted something with 2 or 3 or 4 decimal places, you could change that here. Or if you wanted the column width in terms of characters to be larger, you could change that as well. Now, with subject ID, I'm typically not going to add or subtract those things or using kind of a function. It's just an identifier for my data set. And so for that reason, I'm going to keep that as a string variable. Now, I do need to change if the subject ID has more than 8 characters in it. I'd need to change that. So for instance, in a data set that I might be using, we typically would identify an individual with 3 letters, and then that would be their first, middle, and last name initial. As well as the date that we first saw them in the clinic. And so for that, we would need 3 spots for the letters, and then we would need 2 spaces for the month, 2 spaces for the day of the month, and then we would need 2 spaces for the year. So we would choose if it were 2018, we would use 18. So having that, we would need 6 for the date and 3 for the letters. That would give us 9 characters that we would need. I'll change that to 9 characters. I could also give this a more specific label or something that I would recognize a little bit more specifically. So we'll say subject ID. When we go to these other columns here, I've already mentioned width and decimals. You can change those directly from this menu. The label, as I mentioned before, you could give this a longer name. It's not restricted by special characters or spaces. One of the best habits that you can get into is being descriptive on the labels, so that your variable names that are very restrictive in terms of how you name them could be readily identified within your data set. The next column over is something called values. This column is for assigning numbers to represent groups of people or groups of conditions, or give meaning to what you would typically think of as numeric data. So we'll oftentimes have data that is numeric in nature, but it has some sort of an identifying group or person to that number, and we want to give that value here. Missing is the column where we would assign a number to any kind of data that we would label as missing within our data set. Columns is determining the width of the column and how many characters can be displayed. This is different from the width, which determines the width of the variable itself. So you could have a variable of 10 characters, but the setting on the column width is set to 8. You would only see 8 of the 10 characters. So width and columns, very similar to each other. Width is about what you see. Columns is really about how much is there. So we definitely want to make sure that we have 9 columns here. The alignment just tells us where the data is aligned to within the column. Measure is an important one here. And so measure, if you look at here, you'll see that you could change this from nominal to ordinal. And then you'll also see when you have something that's not a string variable, you'll see scale as an option here. Your measure is how you define the level at which it's measured. So the three options, nominal, ordinal, or scale here, are dependent on the properties of the data. We have nominal data. That means that it's simply a name. Nominal data is something that we're just giving some identification to. Ordinal means that there's some order to the data, meaning that one value would be considered greater than or less than another one. And then lastly, scale data is something that we're going to perform functions with, such as adding, subtracting, computing variables, but then also running some statistical tests with in terms of the dependent variables. And then lastly, a newer variable characteristic that's been added within the past few years is role. And there are some procedures in SPSS that tend to run analyses automatically without you needing to think about what you're doing. So for instance, if you did automatic linear modeling when you're doing a regression, you would have that option. And so when that happens, SPSS actually needs to know whether or not a variable is a predictor, an outcome, or both. And so this is how it selects that. Although I'll be honest with you, it's not necessarily always the same in how SPSS chooses to do that. But oftentimes we'll use, for instance, a grouping variable or something that's a predictor. We would call that an input, and anything that is like a dependent variable or an outcome variable, we would label as a target. In this case, I'll just put none. I'm not going to be using subject ID in any kinds of my analyses or graphs or anything like that. And so once I've done that, I've set up one variable property. At that point, if you click on data view, you'll see that we have subject ID here. And I could go in and enter some data for a set of subject IDs that I might have. So we'll say we saw a set of subjects all on the same day in the clinic. And so these are the subject numbers where we have the initials for individual as well as the date they were seen within the clinic. And then we might have some people who were seen after that. And there we go. So now we have a set of individuals here identified by subject IDs for our first variable. We can go make another variable here. We could put in something like DOB for date of birth. And for that, we might choose something like a date function. When you choose date, you're going to be allowed to put in what it is, their year of birth, in the different format that you'd like. So here you would choose whatever format that seems to work best for you. In this case, I'm going to put the month, day, year format. Again, we don't have any values here. This is an ordinal measurement, technically, because it's date. We're not going to be using this as an outcome measure, so I'll leave it as an input for the role. And we might put some other information here, such as gender. Gender, I'm going to leave as a numeric variable, and we're going to use numeric here and then give it a value a little bit later on. We're going to treat this one as a binary because the data set that I'm dealing with has male and female as the two options on the survey. So for that reason, we don't need any decimal places. So we can put 0 there for decimal places. In terms of label here, we can say participant gender. And here I'm going to use some values. So in this case, we'll say the value of our options here. We've got 0 and 1 would be male. And then we'll treat these as nominal data as well because these are grouping categories. So they'll be nominal. Typically, gender would be used as an input role. Now what that means is when we go back to our data view, we can put in date of birth for these individuals. So I'll put in some dates of birth. Now when I go to put in gender, you'll have the option of actually selecting these from a pull-down menu because we've put in values already. If you try to type in the name, it will go in there. Now that we've entered those, we can continue entering these from the drop-down label if you so chose. Now, one thing that will happen here is that you can actually change the way these are viewed. If you'd like to view the numbers, you can. There is a value labels button up here that is selected by default. If you unselect it, that means is that you're going to see the actual numbers here. So if we put in 1s, 0s, you're going to just see those. But after typing them in, you can go back and select this button and you'll see that it's actually the value of those numbers that gets saved as well. Back in our variable view, entering information, we could put something like a test score, for instance, or we could do, let's say test score, and that's going to be a numeric value. I'm not going to use any decimal places on this. This is in whole numbers. And I don't have any values for this because these are numeric values, so I'm going to choose scale. And this is going to be a target for us. Once we've done that, I can put in our values for test scores. And now we've got some test scores in for our data. And you can, for instance, like this says test score here. If you needed to drag this out so that you can see the whole thing on one line, you can. And that's basically setting up and creating some variables. We've created both a string, date, and numeric data point. Lots of times we'll create sort of coding variables or dummy code variables. So for instance, if we wanted to set up a dummy variable for something like the gender variable, we could have a male and a female variable that we set up where 0 would be not male and 1 would be male. And same thing for female. 0 would be not female and 1 would be female. These variables are often used in dichotomous tests or in different kinds of regressions that you might use. So we might call this one dummy code male and dummy code female. And both of these are numeric. We'll treat these as nominal because they have numbers, but they also have labels that go with them. We would typically use these as input variables, although there could be some exceptions here. And you could do this through an automated form. In SPSS, you could actually go through a process where this would do this for you. With this number of people, it's pretty easy to do. So what I'm doing here is if there is a male for the case, so in this case, case number 1 here, this is a male, that would be a 1 because it is in fact a male. So if you took value labels off, we would say 1 for everything that said a 1 and a 0 for everything else. And if you put value labels back on, you'll see that wherever it says male, it should also say male. Male, male, and lastly there. Anywhere where it said female, it should say not. And we could do the same thing for the female dummy-coded variable. So the first one would be not female, this one would be female, and so forth. It's a little bit easier to me doing this with data with numbers. Then you'll see everywhere it says male, it should also say not female, and everywhere it says not male, it should say female here. So those are just dummy code variables that are often created. It's not necessary that you have to create it for every data set, but wanted to show you how you might do that by hand in terms of creating variables. Now that you have created some data as well as some variables in this data set, you want to make sure that you do go ahead and save if you haven't done so already. You can either do that by going to File, Save As. You'll also see the old school hard disk symbol up here that you could save this document from. When you do this, I'm going to go to Save As, and I'm just going to go to my desktop here to save this where we can find it again. We'll use this one as sample dataset. When you click on save, and you'll notice that you're saving this as a .save file, that is the default type of save file for SPSS. When you click on save, it's going to open up a new window. Thus far, we've been working in what's called the data editor. When you do use any kind of command, whether it be saving a file, whether it be recoding a variable, whether it be running a t-test or creating a bar graph, SPSS is going to open up what's called the viewer window. When we click on save, you'll see that happens. And this is the viewer window. A lot of people will call this or refer to this as the output window. I do that as well. When you see the viewer window, on the left-hand side, you're going to have a tree branching system where you can select different parts of this viewer window or part of the output. But basically what this does is it keeps a log of every command that you run in SPSS. And so the command itself is run by the syntax that you see here. So where it says save out file, you'll see that it's saved on the desktop, a file called sampledataset.save. That's giving you information about the fact that it actually saved that data set. And if we were to go back, I'll go to my documents here. To my desktop, you'll see that I do have sample data set that was saved there just now. The output window or the viewer window is going to keep a track of not only all the commands that you run in SPSS, but it's also going to be the place that in future tutorials you're going to see things like the output from different graphs and tests and different commands that will be useful to you, where you might look at the output and look at the results of those tests to make decisions about your own data and come to conclusions about what you see within your data sets. For now, I'm just going to minimize this. You can actually save this output file or this viewer window if you wanted to open it up later. It's not uncommon that I would run a set of tests and then save the output or save the viewer window because I want to look at it later. So you can save this if you want. Close it. It'll ask if you want to save it because a lot of people do. If you close this out and then go back to your data viewer and run other commands, it's just going to open up another viewer window So I like to keep this one minimized, and then it'll keep all the commands as we go through. It'll keep those running in that same viewer window in that same file itself. So continuing on then, created some variables, created both the numeric and string as well as the coding and date type variables. Once you get some data created in a data set, oftentimes you may want to look at it a little bit different. So one of the things that people often do is want to sort their data. So oftentimes people will want to sort cases based on some criteria. So for instance, if we wanted to sort our data here by highest test score to lowest test score, or lowest test score to highest test score, to see maybe the lowest or the highest at the top, we could do that using sort cases. Now, the reason that might be is, given that we only have 8 data points here, we could imagine having 1,000 data points here. Wanting some organization, sort cases really allows us to do that. So to do so, I'm going to click on data and go to sort cases. Now, I can sort cases by a single variable, or I can sort it by multiple variables if I want. I'm just going to choose a participant test score, a single variable here, and I can choose either ascending or descending. Now, ascending is going to put the lowest value at the top, and descending is going to put the highest value at the top. And when SPSS does this sort, it's going to take the highest test score and all of the data that go with it in that same case. It's going to put it at the top and then do the same thing for the next one and the next one. But it does keep the data for that test score. So for instance, when I look over here, I see that 90 should be the highest test score. And that is for WSJ 180304, female, and was born May the 3rd, 1991. So all of that data should go with that score of 90 when it's moved to the top. Nothing has changed about the data at this point except the order in which you see it. So we'll click on OK. Now again, the viewer window tells me that I've sorted the cases by test score in a descending fashion. And when I look back at the editor, I can see that 90 is now at the top, as well as all the information that goes along. That's sorting cases. Oftentimes I'll have so many cases in a data set that you might want to use only part of them for whatever reason. So for instance, if I were using this data and was interested in only information for maybe women and wanted to look at test scores for women and going to use a bar graph, or was going to use some sort of a statistical test, and I only wanted to include women in that analysis, I could also go back to the data menu and choose something called select cases. When I select cases, what I'm doing is telling SPSS that I only want to view the data for specific kinds of cases, and I only want those cases to be included in anything I do from here on out until I tell it otherwise. By default, when you go into select cases, all cases are selected. However, if I'd like to change that, I could do if a specific condition is satisfied, which is by far the most often used version of select cases. You could also use a random sample of cases if you were using just some random sampling within a data set, or based on a time range or case range or something like that. If something happened along the way that you wanted to look at before something happened, you could do so. I'm going to go to if condition is satisfied. I'll select that option, and then you'll see that this button becomes active. Click on it. And let's say I wanted to use participant gender. I would use the variables over here on the left. I can actually move them into this expression box here and use all these numbers and comparators here to select that specific case. So I might move participant gender over to the right, and I want to say that gender should be equal to 0, which tells me I'm using females only, if you remember the way that we created the variables here. Now, that's a very simple version of select cases. You could get really fancy by using different function groups over here. You'll see that SPSS comes with lots of preloaded functions that you could use within this expression box. You can use these comparators as well. I'm going to keep it simple here and say I want to choose women only in the data set. And so that I've done. I can figure that, I've got to click on continue and then OK before it's actually set that way. But when I do, the viewer window is going to let me know that I did select certain cases here. And back in the data editor, what you're going to see is the same data that we had and a couple changes that were made. The first thing that you should notice is that there are some cases that have a diagonal line through them. Those are cases that are not selected for any kind of analyses, are not not going to be included any kind of graphs or tables that you would run at this point because they are not selected. And the other thing that you'll notice is that there's a new variable here. It's a filter variable. It tells whether or not a specific case is selected. And so you'll see the ones that are not selected are the ones with the lines through them. And those are all the male cases. This filter variable is not useful for anything besides viewing this data. It's not one that you should put in for your actual analyses as a grouping variable. It's not something you should put in for a graph or anything like that. If you need to delete it, you can delete it. I tend not to save these when I save a data set. I don't save the filter in them. But this should give you the clue that there's only certain data selected within the data set. Now, that will remain that way. Lots of people forget that they've done that until you go back to select cases and tell that you want all cases selected, which in that case then removes all those diagonal lines, and it does not update the filter, so you can remove that filter. But that is basically sorting and selecting cases. Another thing that you may want to do is compute a variable. Computing a variable means that you're calculating something, oftentimes including information from the data or variables that you already have. So for instance, if we wanted to see how much above average test scores were, we could do that. So for each individual person here, we could say, how far of a difference is there between this score and the average score for this set of individuals? So let's say that the average for these 8 individuals is 72.5. We could say how much of a difference is there between 90 and 72.5, giving us a positive or negative difference for each individual versus the average. To do that, I'm going to go to transform and compute variable, and I need to have a name ready for my new variable. And so I'm going to say the average difference for shorthand. And if you click on type and label here, you can actually give it a label. And all I'll do here is take the participant test score, again from the left-hand side, just like when you were using the select cases command, you had a list of variables over here to use. Same thing here. You've got a list of variables, comparators and operators, and lots of functions here. We can move that over to the right. Then I'm going to use the subtract button and then put in the value of the average score. Once I do that, I can click on OK, and then you'll see that I have a new variable that is average difference, and that tells me that a score of 90 was 17.5 points higher than the average, whereas this person who scored a 32 was 40.5 points below average. And so we can compute variables in a number of different ways. If you go back to transform and compute variable, one of the things that SPSS does a lot of is saving the last thing that you did. So if you happen to make a mistake, you can try to locate that mistake and not redo a lot of work, or everything went fine and you wanted to start from scratch, you can hit the reset button. One of the things I will point out is that if you wanted to use some different functions here, let's say we wanted the mean, if you click down here, you'll find the mean here. You could move the mean over and put in different values here from the left-hand side and create a mean of multiple variables within your data set. You could do the logarithmic function of variables because you might be changing something for transformations. You might look at using different descriptives here. So maybe you want to find the medians for multiple values. You've got a lot of options here when it comes to computing new variables. So make sure you take advantage of those and you explore that a bit. Another thing that people often do when creating and manipulating a data set is recoding values. So for instance, if we have a value or a set of values that we wanted to change into another set of values or a descriptive set of values, we could use what is called recoding. And when you recode, you typically go to transform, and you've got 2 recode options. Sometimes people recode into the same variables, meaning that you're taking a value and recoding it and replacing that original variable. And then other times you might recode into different variables, meaning that you save the original set of variables after you've recoded them. I often find recoding into different variables the safest manner, especially if you're taking something that is numeric and putting it into something categorical where you're losing individual information. I find that the easiest to do if you need to go back for some reason. And that's the option I'm going to choose, although recoding works the same for both of these. Once I click on recode into different variables, I need to choose what variable that I'm choosing to recode in the first place. And so I'm going to go back to test score here, and I'm just going to change these into letter grades. Given that they're out of 100, pretty easy to do that. I'll move participant test score over, And then in my output variable information here, which I do need to put in, we'll put and I'll click on change. And so that means that we're changing test score to score category here. You can change these using an if function or old and new values. Old and new values tends to be the way that most people do this. So I'll click on that. And this is another submenu that gives me on the left-hand side, the old values. On the right-hand side, the new values. So over here, my old values, I know that I have numbers, and I want to get to letters for the grades eventually. I do not recommend changing numeric information as an old value to a string variable. I think a much cleaner way to do this, even though it's an extra step, is to actually change numbers to numbers and then give value labels to the new set of value numbers. That's what I'm going to do here. We'll say, we'll give, anything that is a 90 and up is going to be an A. Between 80 and 89 is going to be a B. Between 70 and 79, a C, and so forth. And anything 59 or below will be an F in our data set. And so we can start there and say our lowest value through 59 is going to be a 1. And then my range 60 through 69 we'll call a 2. It is important that you remember as you do this what these values are. Now, another thing that it will do in the viewer window is it'll keep track of this. So if you don't write this down as you're doing it, the viewer window should keep this information for you. I need 70 through 79. One of the common mistakes that I see students making oftentimes is having overlap in their ranges. So they'll have 60 to 70, and then 70 to 80, and then 80 to 90, where anything that would be on that board would actually be counted in both of them. So that sort of skews your data a bit. So you want to make sure that you do have fine boundaries here. Also keep in mind that if we're dealing, as in this case, we're dealing with whole numbers, we can use whole numbers here. But if we were dealing with decimals, we'd want to take that into account with our range. Here we'll go 80 through 89 is a 4. And then our value 90 and up will be an A. And so that's going to be a 5. Up to 59 is a 1. 60 through 69 a 2. 70 through 79 a 3. 80 through 89 a 4. And then 90 through the highest is going to be a 5. I'll click on continue and OK. And then, as I mentioned, the viewer window will keep track of what your recoding actually looked like in terms of what the values were. Go back to our data editor. In the data view, you'll see that I have numbers here. One step that I can take to make this a little bit cleaner is that score category was numeric. I do want it to be nominal. However, I want to give it some values. And so for a 1, I'm going to call that an F. A 2 is going to be a D. A 3, a C. A 4, a B. And a 5 is going to be an A. Click on OK. And then back in your data view, you'll see those letters that represent the different scores there. And you do see that it goes down in order because remember we did sort our cases earlier to where the highest was at the top. Again, you can take value labels off to see the raw data there. Click it again and it will put those value labels back on. And that's the basics of creating a data set from scratch in SPSS, making sure that you set the proper attributes and properties for each of your variables. We talked about the different views in SPSS, sorting and selecting cases. We computed and recoded variables. So after that, you're going to want to do some of the things involved in analysis. And so there's a whole lot of analysis tools here. A lot of people use the graphing abilities in SPSS. Those will all be talked about in a different tutorial.